Hello, this is the Brock and Dave Drillercast. I'm Brock Yorty, and my co-host is right next to me, Dave Bowers. How's it going,
How you
Dave?
doing, Brock? How's everybody today?
It's good. It's a good day. Weather is cooling off, even down here in Florida. How about up there in Illinois?
Yeah, we're beyond cooling off. We've been last 2 days. We've been below freezing for a good chunk of the night. So,
We'll be wishing for fall when it's all that white junk and ice, and our days are shorter and all of that.
well, I think I'm going to be wishing for spring. I don't want to. I don't want to get rid of spring and summer. I'm going to wish for spring.
Well, before we get started today, we've been doing these safety moments, and I want to talk about lockout tagout. I had a situation on a test engine on a turbine pump, a diesel test engine. They were working on the unit, and I asked, are we all locked out, tagged out? And everybody said, of course. And then as they were working on the unit, the employee had somehow arced on the wrench to the starter, and the test engine fired, and the PTO, which has guards on it, but we were working on, that drive, spun with an employee right there, and he jumped back. Nobody was hurt, but I immediately shut the job down and got over there and said, guys, what are you doing? What what about lockout tagout did we miss here? And one employee went, dude, this isn't electricity. And
Well, and I think that's a common thing that people think. Well, lockout, tag out. I look at the electricity, but what OSHA says is energy, and energy could be spring energy. Think about we all have trailers, right? We all have semis. Have you ever had to change a pancake? If you've ever had to change a pancake on a brake, boy, you better cage that spring because that energy will kill you. That's what lockout, tag out is. That caging bolt is in fact lockout tagout. It's any type of energy has to be either neutral or contained, and it can't be released.
and that's the same thing. In Afghanistan on the V2000, a employee got hurt, not a military employee, got thrown from the rig because he was hammering on a hammer union. And when he went to Bagram, and they had to fly him to Germany because he broke both arms, dislocated his shoulder, and did something really bad to his hip. And the discussion came, he goes, well, it was really hard to put that hammer union on. And I just figured it was hard coming off, and that's common sense. If a hammer union never tightens up, what's going on?
Yeah, there. We always tell every apprentice, every new driller, no matter where you're at, it doesn't matter. I mean, I always call them apprentices because that's what I deal with. But anywhere, one of the first things that you learn is walk every single line every single time. During setup, before you start a new process, if it's air, mud, whatever, we walk the lines, make sure everything's tight, make sure everything's in the position it's supposed to be in. There's not too many things worse than letting a lot of fluid or air go and have something come loose, and now you have something whipping around. We had a gentleman get hurt like second or third day on the job. Not a drilling apprentice; he was a regular operator apprentice, but they put him on a simply watching a compressor in support of operations, and he didn't get they didn't have the right type of fitting. He didn't know what he was looking at, and so when he had a fitting let go, that hose come around and smacked him, and he wasn't badly hurt. But that should never happen. That's why we have different types of whether there be whip socks or whip what do they call the one that's just a cable, just a whip chain or whatever?
Check.
A whip check. Thank you. You know, and then we also have to understand that we need a whip check is good up into 150 psi roughly. Above 150 psi, we're supposed to have whip socks, right? Which is like a Chinese finger over the hose, and then two lines that are bolted together. Either there's a bolt, but if you've got two hoses coming together, there's a bolt that runs through the two pieces, right? So that we have a more secure fitting.
And that's the whip sock, and that entire concept came from when we start looking at these big 2 and 3 inch fluid hoses that we put under pressure, being if it's air or mud. You know, there's a lot of pressure there, and however that hose decides to pull apart, it's a weapon. And Jake Fletcher and team saw one on a brand new 50K blow apart with me on the controls. And I'll add those photos to our Drillers Tribe, you know, www.drillerstribe.com, and you guys can see those photos. But it's that situation of that's why the sock became more important, including when we change out those fluid lines, those pressure lines. I see them get hooked back up, the cables, the chains, the old style bolt, like what do you want to call that, a collar or a bracket, and they're not even hooked up properly to the way that, you know, if that line gets away, that hammer union on there will kill you.
So are we talking about the boss fitting going back on? Is that okay? So I had a boss fitting come apart, I don't know, maybe 15 years ago, and had the hose come down and wound up hitting me on the head as the hose came down. It was from the top head and was still hooked at the top head. It came from where the standpipe was, and that was only a fall of maybe it straightened out a couple feet. And you know, I've been hit a few times, but that knocked me to my knees, which, not, you know, there aren't a whole lot of things that would knock me to my knees. And I saw stars for a minute.
Well, Dave, how tall are you?
I'm 6'3".
Okay. I'm 5'11", barely. And when that fluid hose busted, I was short enough that when I heard the pop and realized what was happening, I knew I couldn't move off the platform, because any direction I went other than where I was, I just tried to make myself small as possible. You're already in that danger zone. I have to step on 2 steps to get to where most of those hammer unions are, where you on your tippy toes can pretty much reach and see if they're tight, right?
For the most part. I mean, I'm not, 7 feet. I still have to climb up on stuff to tighten them up. But what happens is you wind up, I don't know how to say it. You wind up, after it happens, questioning yourself, because we're supposed to inspect this equipment every day. I'm supposed to walk lines down. So how did it happen, right? How did I let that happen? And luckily it happened to me. I was the driller. It happened to me, and it was my responsibility, and no one was badly hurt. I actually wound up taking, I think I got 2 stitches out of the deal, and I had a hard hat on, and it got me, but when it glanced off my hard hat and it hit me in the hand, and I wound up with 2 stitches in my hand, because, but it's my fault. Right? And here's the thing. It's always your fault if you're the driller, just about, no matter what happens, because you're the one that inspected the rig. You're the one, there are only very few real accidents. A real accident is something unforeseen that nobody reasonable couldn't. We knew that we probably should have replaced that, right? It didn't look great anymore. And you look at the hose and you're like, well, it'll probably make it. And like anyone who knows me knows I'm cheap. And I'm really reluctant with my money or the company's money, reluctant to spend money that I don't have to spend. So I had, we'll make it go another hole. We'll make it go another, yeah, it's fine. It'll run. And everybody says that stuff in their head until it doesn't. And then you're like, man, I should have done that. And luckily, like I said, no one badly got hurt. It was me that did get hurt. Because you've got to put that somewhere. If it's a helper or whatever that gets hurt, now that's it's going to weigh on you personally.
So there's two things here. And with my fake audience that I have, I saw a question come up. Is it always unforeseen or one of those situations of just equipment wearing out? And I say no. So there's three situations. There's the unforeseen because of we're a rough and tough industry and equipment wears out sooner than it should because of the disruptive drilling process. And we'll get into that. There is not knowing or not having the right process in place. And the one that upsets me the most, and it's important for us to address right now, is just negligence and sabotage. Or, that is the one that if I'm the driller on site, if I'm the supervisor, and somebody doesn't put on their fall protection when it's there for them, they went into a confined space without, using a 5-gas meter and understanding, those are the ones that we have to immediately stop. Either that employee goes on leave so they understand how the severity, because putting them on leave for a week or terminating them. And there's this really great safety guy in the Midwest for the company I work for that said, guys, I care about you so much that I'd rather have you not working for the company than looking at you in a box. And so, as we look at fluid lines coming apart, those type of things, but the one that really gets us is that time when I don't need my fall protection because I'm only going to go up, three pieces of the lattice onto this 30K.
Well, there's something that everyone has to understand, right? When I give you personal protective equipment, I am telling you, I can't protect you any other way. Because I went through the hierarchy of controls. I've said, can I isolate you from the hazard, or can I eliminate the hazard together? Will a rule keep you somehow, or what they call an administrative control, will that keep you safe? I've determined on all those things no, so all I can do is give you something to use or wear that will protect you from the hazard. And so if I'm doing that, I'm basically saying, hey, you're going to be exposed. This will prevent you, hopefully, from being hurt. Right? Being exposed to a hazard, being hurt by a hazard, different thing. I'm giving you personal protective equipment to say, I don't want you hurt, but you will be exposed to the hazard. We're going to mitigate that hazard by giving you this item. So when someone doesn't wear, whether it's like me, I've been guilty. You hear how I talk. Luckily for you guys out there in podcast land, Brock evens us out. I'm screaming. Now, I'm not really screaming, but most people would consider me screaming when I talk at my normal volume. I get a lot of people that say, hey, why are you yelling? This is just how I talk. I was probably loud before I lost a bunch of hearing, but I'm definitely loud now. Negligence. They were available to me, right? They were available to me. I should have worn them. I've written about it. But that macho culture, or, hey, it's only going to take me a minute. Well, how long does it take to fall? How long does it take, accidents or incidents happen in a split second. And I've looked around at these different shows and stuff that we go to at our fellow drillers and helpers and owners, and I haven't seen too many people who look like they're fast twitch muscles are so in tuned that something is split second and they're going to be like the speed force on the other side of the rig. That's not realistic. We are not, most of us are not top athletes. And even if we were a top athlete, as we get on later in our years, maintaining that athleticness, because we go from being the helper or the guy that was an athlete, but now he's picking stuff up and he's moving. Now we graduate, we become the driller, where our responsibilities are different, or we become the owner of the company, or a tool pusher, where my responsibilities become, hey, I'm shuffling a lot of paper, and I am going out monitoring what my crews are doing, making sure I'll jump on the rig when they need my level of experience. But for the most part, I'm monitoring. I'm no longer doing the physical things every day. So maintaining being that in shape, it becomes difficult, because now in order to do that, you got to go work out and do these other things. We spend an awful lot of time at the job working out. I've struggled for years where, okay, I got to go to the gym. Well, you're working 10 hours or 12 hours a day, then another 2 hours at the gym. Eventually you get tired of that. And what's the easiest thing to cut out? You can't change the work schedule. So you wind up not working out, not doing the things you should.
Right. And, so we started, because safety is such a big component of our industry. We started with energy from a lockout, tag out, making sure that we're looking at our lines, we're disconnecting batteries, we're changing the energy, and there's lots of different energy on a drill rig, including the energy of you falling and how you're going to be stopped. And we've gotten into, how we treat our bodies, because that's how quickly this shifts into our industry. And it's important for us to all address this. And I want to get to today's topic. So we're going to push on. I think we can get Glenn and a couple of our other safety guys on and just have a full hour on safety. And it'll probably be the least listened to podcast because of our culture. But I'll leave us with this. Had a great colleague that had worked in blast hole and on different rigs all over the world. And up until he was like 74. I haven't talked to him in a while, but he would always look at me and he'd hand me my hearing protection and he'd go, "Hey, Brock, I called the tinnitus hotline, but it just kept ringing. Why don't you put these in?"
That's funny. All right, so here's how I'm going to combat that. That will be the least listened to. If we use Glenn Minyard for our safety guy, and actually, to be honest, I've been pleasantly surprised how many people who have come out and offered, hey, if you want, subject matter expert on this, I would come on, and we're going to bring some more people on. But if we bring Glenn Minyard on to talk for safety, there's no better safety guy. Besides that, he's the person who was willing, before he was a full-time safety guy, to start an argument with the nuclear option. So I'm sure we can still make it a entertaining podcast.
I think so too. So this week, I want to talk about, the tribalism of how we make a borehole, how we make a hole in the ground, how we've learned this, and then move into, the point counterpoints of the technical aspect from the learned aspect. And this came to me, Dave, you posted something on Facebook on sonic drilling, and it was Geo International's article on sonic drilling. And it was an adequate article. And I can say that because I write often, you write often, and it had everything you needed in there, but it didn't get into the reality, other than it was calling sonic, the new innovation in drilling. And sonic was an innovation in drilling in 1995. And I'm sure there's guys before that who would say before that. And now we're getting into massive technological advances. It's kind of like looking at the Chevy Volt versus the Tesla Model 3, in where Sonic has gone from an electric car to what Tesla is doing these days. And I made the joke that, those Sonic rigs work really well until you wash them too much and all the gnomes drown. And then you got to order more gnomes from Holland. And that's because, some of this stuff in drilling, we know it works because it works, but we don't really get into the foundation of it.
Well, not many people realize that gnomes are how things work. Because anything that you don't understand that just works, it must be gnomes. So really, I think to talk about any of these things, it comes back to how do you make a hole? And it doesn't change necessarily, no matter which discipline to make a hole we're talking about. Principles are all the same. And the first thing we have to understand is geology is what plays the biggest part in making a hole. Because our cutting or drilling action, whatever we're going to have, it's going to have to remove material or at least break material free from where it wants to be. If it's a soft material, we're going to want some sort of a tearing action. If it's a hard material, we may need a crushing action or a hammering action. So that's something that we really need to understand first. What are we drilling in? And then
so I want to pump the brakes real quick, because I know the guys out there and the guys out there, and sure, we can jump right into the science, but science isn't what is running this industry. And it is cutting action, right? If I yell at my smart speaker and ask it, how we do this, it's going to say that it is cutting action with rotary pressure of some sort that is going to make a hole. Now, geology means nothing if I put a 330,000 pound rack and pinion oil and gas rig on top of something on surface, because what can I do? I can break the fracture gradient of anything with enough force, with maybe not the best bit. And we've seen this. We've went to the field and we've said, I'm going to drill this rock today with this medium tooth, mill bit, because I don't have a good button on here. Or we got the guys that say with PDC, I just got to do 2 or 3 feet of this unconsolidated and I'll be back into the competent rock. And I'm just going to do it with this PDC because it's easier than tripping out. So what do? We
tear up a PDC.
Right.
That's what we do. But here's what I want to say to that, though. You can only go to the dance with the girl you've got, right? So I don't have that 300,000 pound oil and gas rig. And I would bet if we talk to the oil and gas guys, which is something that we should attempt to look at a little more, something we don't really marry a whole lot of the oil and gas stuff with what we do, but drilling is drilling. We might want to look into talking to somebody from that industry a little bit. I know you know a few.
Yeah, they're not working right now, so they're probably available.
Yeah, I know.
Water guys, geotech guys, and geothermal guys, just pump your fist in the air and go, damn right, we're still essential.
Yeah, well, here's what I'm going to say. That guy that's the driller for that would also tell you that geology matters, because he's going to change. He might be able to break the fracture gradient and just let it ride, but he still needs a good hole, still needs to be straight.
Well,
and it won't be. So technique comes into it, but the physics of this is what's kind of important, right? The physics of how to make a hole, and I think we should kind of go back to that. Stuff that's basic, the 101 stuff. Hey, if you have a soft material, what kind of tooth do you need? What kind of cutting action do you need? I need a long tooth, whether it be on a hammer bit or whether it be in an auger or whether it be on a mill bit or a button, the softer the material, the longer the tooth. The harder the material, the shorter the tooth or the cutting surface is going to be. And that's all determined by geology. If I use that long tooth and we get in hard stuff, how am I going to cut? It might cut, but it's going to be slow. It's going to wear out the stuff. There's why there's different designs for everything.
So again, we can cut anything with any tool if we have enough time. And that's what you've said. You know, when we determine geology and we start thinking cutting action from a rotation standpoint, and we see this from older table drive rigs that can't get us the RPMs that we require to run an effective PDC bit, or the amount of down pressure that we can get out of a top head. And depending on the piece of equipment, because you just said this, we need to know our limitations of our equipment, which give us the expectations of our drilling time, and then why we want the right tooth, why we want the right rotation, why we want the right bottom hole assembly with good weight so that we're not just pushing from the top, or maybe we don't have down pressure because we have a table drive rig that doesn't have that to apply, is to mitigate that disruption, right? So I can take a 3-pound sledgehammer right now and try to hang up pictures with it. And with that little nail that I need, there's a good chance I'm going to put a hole through the wall. Or I can use the right tool and I can tap that into place and I can hang that photo. And that's the first thing we have to understand is everything that we line up back to your physics and science gets us to being able to surgically put this hole in the ground versus drill baby drill.
Well, drill baby drill has its place, but it's after we've got all these other things right. Because drill baby drill is really about being efficient, but we can only be efficient with the right stuff. Everything has to match. I have to have the right bit that I need. I have to be able to not only make cuttings. Anybody can make cuttings, and I think that's the key. Anybody can make cuttings. I've got to make cuttings that get out of my hole. They've got to come out of my hole, and they've got to leave me with something that is rifle bore to the closest as we can. And that hole has to stay open. And I always talk about physics, but gravity doesn't want anything to stay open. If it did, we would walk around and there would be, all these sheer cliffs that are just sheer cliffs all over the place. Nothing stays sheer. Even a mountain, a sheer cliff only happened because something came off. Look at the bottom of a sheer cliff. You'll have usually, you'll see where the rock has come off and you'll have a slope there. It's gravity wants to pull everything down to the lowest level. And that's the first thing that we have to understand, is that we're trying to tell gravity, hey, it's okay. We're going to figure this out and we're going to stabilize it long enough to complete what we're going to do. And there's a bunch of different ways to do that. We could use mud, as you said. We could go ahead and case something off if we believe it's going to stay open long enough. We could use a foam to do some light stabilization. And if that's not enough, we could mix a gel foam to go. So there's a lot of different things we can do to help make stabilization, but none of them mean a damn thing if the cuttings don't come up and out. If the cuttings stay around the bit, we're going to get stuck. If the cuttings go worse out into the aquifer or out into the formation, now if we're setting a water well, we've sunk ourselves, right? Because now we got to develop that, and we got to do, and that's beyond the drilling process, but it all matters. The drilling process winds up being important to the final product. And that's why there's an entry-level driller that's never drilled a thing in his life is a danger to himself, not only safety-wise, But if no one is guiding him, if he's just starting from zero and he's got no education, the likelihood of him having good finished product and not damaging aquifers and causing issues is high, because he hasn't had any guidance and he doesn't know what he doesn't know. And
I think we got to circle back, Dave. We're getting ahead of ourselves. So we have a cutting action, and that's preventing the disruption. We have to be able to, what we cut has to be able to come out of the hole. You've said that gravity shifts it so it's going down, but Dummy's Guide to Cutting Action. We need to make cuttings that are a ½ inch to, basically look at the size of a quarter in the States to a dime. I'm not going to get into what Canadian currency looks like because you guys are all over the place, but I think a toonie is probably too big to come out of the hole. So what we're looking at is making ½ inch to a quarter inch size cuttings that can effectively get away from the bit face, go up hole, and then we separate them out once we get up hole. So Dave just talked about fluid medias, and fluid, or our way of carrying cuttings out, is anything is a fluid once we put it under pressure and we send it through, the drill stem, and we're heading down hole. If we're doing conventional rotary, that's not reverse right now. We're just talking conventional. So we're sending a velocity of something downhole that is going to help us fight gravity and bring it up. We're not talking hole stabilization or anything else right now. Just what does it take to get those cuttings out of the hole? And science says in water, mud, we need 60 to 150 feet per minute uphole velocity to break that gravity and bring it up hole. So if we think of the space shuttle taking off, look at all the boosters that are around the space shuttle before it breaks gravity, before it gets past that slip velocity. So you design your borehole and you only have that 200 gallon a minute pump, and it says when you do your uphole velocity calculation, you have 60 feet per minute uphole velocity of a fluid. That ½ inch cutting is not moving at 60 feet per minute. So what happens to it as it's going up hole? It disrupts, it breaks apart. Just like if the rocket can't break slip velocity and it starts vibrating, what is it going to do? It's going to become smaller pieces so the pieces can keep going up or they can come back down. So when we start thinking of disruption and our cutting action, it 100% comes back to the size of the cutting we're creating and how we sweep it out. Obviously, unconsolidated soils, and I don't think today should be a geology lesson at all. We just need to know that sands, gravels, and rocks, we can break up into finer pieces than we can big clays and shales. And we need to have cutting sizes that are easily carried out of the hole. And then we can get into what we're going to push downhole to bring it up. And that's where Dave's getting into stabilization right now. And I'll hand it back over to Dave. But we have to understand that we have to make a cutting that is manageable to bring to surface. This is before we get into solids control or recirculation or anything. The basics to drilling is we're creating a hole by making cuttings that can come out of the hole. Then we have to determine what we're going to use to sweep them out of the hole.
Well, and first off, right, how do we know what that uphole velocity is? We got to do that calculation. And I know when I was when I was coming up, the one thing that I teach every single year that was never taught to me was the math behind all this. And now they've made it super easy. And I don't allow my apprentices to use this, by the way, but now every fluid company has an app for your phone that you can click in what your pump is pushing, so first off, that's the first thing I got to know. What am I pumping at? Just because my pump is rated for something, it doesn't mean that's what the pump is pumping. And then I have to understand that what the annular space is between that rod and the outside of the hole, so that I can calculate those things. But once I know, either I pump it into my app, or I can take my pumping velocity, right, and my annular space per gallon, and whatever I'm pumping at divided by my annular space per gallon, it'll tell me what my uphole velocity is. We'll get in. I'm not going to get into the math behind that. It's pretty simple, right? It's a very simple math. I'll give you the equation. And this is what I use all the time. It's simply diameter of the hole squared minus diameter of the rod squared divided by 24.52, or even if you want to go simpler.
Don't do it, Dave.
I don't like it. Well, I've seen people that in mud schools decide that it's not 24.52 just to make it easier, but it is 24.52. And then that'll give you the gallons per foot. So once I know my annular space, gallons per foot, all I got to know is what my pump is pumping. If I know that that space is 2 gallons per foot and I'm at 200 gallons a minute actual pumping, that tells me I'm at 100 foot a minute. I would be able to drill that, right? And then I have to understand that that's where my starting point is. And then as that range, that 60 to 120 that we're at for a mud, I have to understand that as my velocity goes down, the buoyancy of whatever I'm using has to be increasing. The same, if I'm just water, 60 feet a minute is probably not going to be enough, and we're going to break up those cuttings that you're talking about. So a lot of this comes to that last podcast that we did, using the correct polymers and all that stuff, so those cuttings do stay as close to in one piece the way we broke them up, and then they reach the surface in that condition.
So Dave means the mud podcast, because if you're like me, I just pick whatever one looks interesting to me. But we do have a podcast on the basics to mud that is out there, and you can talk to your mud engineers and you can design these things. And the app is great. It's optimizing what it takes for the cuttings to come out of the hole. Here's the deal. If I can get a strainer and I can look and I can see that I have cuttings that are coming up that are 1/2 inch to 1/4 inch, and they're coming to surface, and my mud weight going down, if I'm using fluids right at that 8.45 to 8.6, and they're coming up and it's 9 pounds, and then those cuttings are settling out, you're making good hole. And as long as when you break a connection, you're not seeing settling and you're seeing fluid come up, the negative pressure of that rod and spurting out, we can maintain that. So the science is there. The uphole velocity calculator is there to maximize what you're doing, but don't get crazy into, I have to achieve these, because it comes back to limitation of our equipment and time it's going to take. And if you're successfully making holes without any of this, it is really good to know, hey, I need cuttings to be this size so I can sweep them up out of the hole to maintain borehole stability or stop the disruption, because drilling is a disruptive process that is tearing, cutting, smashing, spraying, everything in our downhole conditions. And those are things we have to maintain. Unless we're out west and you're going to drill 1,000 feet of just straight rock and you can just damage the hell out of it and not see a major ramification other than you're seeing it on your tooling and on your rods. It comes back to, and now that's where Dave's geology comes in, is we can be meaner to things that can take it, but understanding our fracture gradient and what our downhole conditions can take before they change. And so we have what's called equivalent circulating density. And damn it, we went into the science and physics way before we wanted to. But our borehole is able to take so much pressure before it breaks. Sometimes it breaks and it doesn't completely destabilize. We just start losing fluid. We call it fracking out. So if you think about, I was really bad in wood shop because there was this Amanda that was gorgeous, and I would much rather flirt with Amanda than do my woodshop stuff in high school. And for you kids out there, woodshop was this class that had all these great tools, and generally a teacher that was missing a finger, maybe an eye. He was some sort of veteran, and he was really crass, but he taught you how to build birdhouses and cutting boards and fun things like that. I know that's something that doesn't happen anymore because we're not.
Brock, your wood shop was lame because we had, I mean, I don't know about Amanda, but your actual wood shop was lame because we were building furniture. I was a cabinet maker right after I came out of high school because I was good in wood shop and gained those skills. What I didn't understand is that, you know, the money in cabinet making, not as good as the money in drilling. But
I need to make my point on woodshop real quick before you go on. And one, cabinet making with you so close to the Amish and me so close to the Amish, you're never going to beat them at cabinet making. They don't pay electric bills. So we'll get into that another time. But in woodshop, we had to make a birdhouse for my mom for Mother's Day. And our school was a small school, so we didn't have all the tools. I graduated class of 60. So we had the basics and what got donated from local places. And we were a big farming community, so there weren't a lot of shops. So I got a hand drill, all my pine boards. I went and cut to shape. I got everything right. And instead of pilot drilling each hole and then going in and placing my screws, some guys were doing pegs and making it really fancy. I just wanted to screw the bastard together because I was 17 and I needed to get back to finding out if Amanda could go to prom with me. So I got all my pieces and I glued it, and then I just drilled everything in, and I gave it to Mom, and Mom thought it was great, and it made it from September to December before it just fell right apart because I split that pine. And our ground is no different than the ability to fracture or split or crack a piece of wood. And so we're trying to go in and surgically drill this without breaking that fracture gradient. Because let's face it, if once we break it, no different than if I crack a good piece of oak, if I'd ever gotten into cabinet making, and then I start gluing on it or I putty it or I do whatever, it's never going to be as strong as it was. So Mother Nature did this damn good job of layering this stuff the way they wanted it, even as the glaciers came through. You know, we have this good competent ground, and then we go in and we mess it up. No different than me messing up that birdhouse. By the way, Amanda did not go to prom with me.
I was going to ask you for the entire listenership how she turned you down. But
wait, yeah, she had to turn me down?
Maybe, I'm sure she had to turn you down.
Maybe she's going with her boyfriend from Canada. There's multiple reasons why.
Did you ever meet this boyfriend from Canada?
You know what? With his beady eyes and his flappy head? No, I never met him. South.
Anyway, I like to do exactly what you said makes sense to me. I like to tell people what we need to be is a lot closer to that twist drill bit. Because here's really what fracture gradient is. We'll stay with the wood analogy. Take a twist drill, a good sharp twist drill, and drill through a thick piece of, I'll stick with construction wood, pine, right? We won't go to, but as you drill through, you're going to go a little while and you're going to pull back and you're going to let those cuttings come free. And you're going to go in, you're going to pull back, and that twist drill is going to remove everything for you. And then if you, at the end, when you're going to break through, as long as you go easy, it'll make a nice, smooth hole. That compared to when we do, that's when we do things right. Everything removes out of the hole. When we don't do things right, we're like a blade bit. You go in with that blade bit and it makes a hole. It makes a hole, but it makes a mess and it doesn't move anything out. And when it breaks out the other side, it just blows stuff apart. And that's exactly what we're talking about here. When we get everything right and we make the right size cutting and we don't over drill things, right? When we under drill it, we don't really get the cutting we want. We over drill it, right? Those cuttings tumble down there and they get broke up more, or they have to go somewhere. When we get everything right, we're that twist drill. Everything comes out and we make that nice shiny bore wall. When we don't get it right, and now we're worried those cuttings are going somewhere. So if they're not coming out of the hole, they're either packing our bit in, but if our bit isn't getting locked in, where'd the stuff go? That's why they call directional drilling, when you're doing it on a small scale like utility stuff, that's why they call it boring, because they don't remove cuttings. They push cuttings out of the way. They push everything over just long enough to pull in their product. And we don't want to be borers, we want to be drillers. Because if we're borers, we've messed up the stuff that we're supposed to either be sampling, right? Because if we're a geotech driller, we're supposed to be getting good in situ samples. If we're a water well driller, we're pushing everything into the aquifer. We don't want to change the geology. We want to make sure that we have a representative sample of the geology. So as we drill this hole, we do everything that we can to make sure everything comes out. And that sometimes may mean slowing down a little bit. It might mean screening those cuttings and seeing what size is coming out. It means knowing when to change tactics. Because most places, you're not going to have a single geology, a single type of thing that you're going to be in. It's going to be mixed geology. So what works in the top 100 feet of the hole might not work for the bottom 100 feet or the bottom 200 feet or the center section. It doesn't matter. So we have to understand, when do we change? Maybe it means that we drill a large diameter hole in the top and we set some sort of long string down to string that off. We cement that in, and then we go with a different method inside underneath. But understanding when to make those changes is the difference between someone who's pulling the levers and someone who's become the driller.
And that's it. And that's why we're back. That's why this is a fundamentals discussion. And we've spent, 30 plus minutes talking about cutting action and rotation. And it's because drilling's a system. Jeff Blinn was the one that kind of brought this entire concept together for me, but it's one of the reasons why I wanted to work for a fluids company and a drilling company and get back to the field, was to understand how the system works. And if we understand that it's a cutting action that is followed by a fluid moving those cuttings out of the hole, and how we have that bottom hole assembly, how we have the rotation. Dave just talked about where are those cuttings going. We're able to look at rotational torque. We're able to look at, are the cuttings coming out of the hole? Because it's not a hole if the cuttings aren't coming out. And that's what the horizontal directional guys, which we've not talked much about, and we can have a whole cast on that because I've spent a lot of time on some big HDD jobs. It's just, it's different. It's very much different. They can't circulate like we do. With an exit pit, it changes the dynamics of drilling. And so that system is dynamic. That's the big thing to think about. Cutting action first, followed by the rotation that you have of that cutting action is going to determine your cutting size. Your geology is going to determine your cutting size. Then we're bringing it out of the hole, and then we have to continue that. And we have to understand that the physics of what it is coming out of the hole and how deep we are. And I like to say 0 to 300 is pretty straight to the point for depth of drilling. Even you Canadian guys out there, I hear you all the time talking feet. So I'm not going to go into meters. This is the USA that we're doing this podcast from. Dave's got American flags in the background. And depending on when you listen to this, who knows who our leader is. And that's not even a point we need to get into, but we're going to talk feet. So 0 to 300, we can get away with a lot before the complexities start to kick our butt. 3 to 500, you're going to notice we have in-train solids if it's a mud. You have to increase your air capacity if you're running straight air. We've now encountered a couple different aquifers possible. You're getting into rock that's never been, disturbed in some parts of the country. And then that's when we get back into, all right, what bit are we going to use? What is that cutting action? What is the rotation I have? Are we going to case it off? Are we going to cement? And again, casing and cement and running multiple strings of, casing, intermediate casing, final casing only works if we mitigate that disruption on top. So the last piece I want to say is, as we consider, we're going to drill this as a pilot hole and then we're going to open it up. We're doing the pilot hole so that we, just like with my birdhouse that I sucked at, and my dating apparently when I was 17 that I sucked at, we can either fail right in the beginning or we can set ourselves up to be successful. And that's by mitigating the amount of impact we do to that borehole, because the smaller the diameter that we start with, one, we get to take cuttings out, we get an idea of what we're going to react to, just like Dave said, where we now have a baseline of what geology we're going to encounter when we open that up. And the next thing is it's easier. We have less pumping action. We have less solids to handle, because we talked about, the diameter of our drill pipe, the diameter of our bit, squaring it, dividing by 24.52. But here's the one, and every mud school out there, depending if it's Wild Bend, Setco, Bayreuth, MI, they all talk about this bit diameter and how it comes out. I'm a fat kid and I really enjoy pizza. So think about it this way. An 8-inch pizza to a 14-inch pizza. How many more slices are there? So we're looking at pi r squared, because I are hungry all the time for good pizza. So if you have a 5-inch bit, we square it, that's 25, and we divide it by 24.52, we have 1.02 gallons per foot. So now I want you to think about that 10-inch bit. That 10-inch bit, 10 times 10 is 100. Most of us automatically go to 2 gallons per foot, but it's 4 gallons per foot because of pi r squared. Why is that important? Because a 5-inch bit for our geothermal guys, or even when they're using a 6-inch bit, 7 feet is a cubic foot of material they've drilled. In a 10-inch bit situation, 2 feet is over 1 cubic foot of material drilled. So a 5-gallon bucket is 0.7 cubic feet. If you think about that, how many 5-gallon buckets are you bringing out of that hole when we're looking at that cutting action and the fluid motion to bring it out? And that's really important in our disruptive process. And from a pilot hole of doing a 8 7/8 hole and then opening that up to a 16 or an 18-inch hole, how quickly we can go from, 2.8 gallons per foot to, I'll run the math while Dave's talking about his next point and give you what an 18-inch bit is.
All right. So this is a thing too. You have to look at some of this stuff before. When you get to the job, it doesn't help you because you've got what you've got when you're at the job. Hopefully somebody at your company understands a little bit of this, who did the bidding, so that, and if you're the guy doing the bidding, I really hope that you understand some of this stuff. But I had this is why I was thinking of it. Someone asked on a Facebook page the other day what the best way to drill a 40-inch hole to 120 feet was. And the answers that I was watching, I didn't comment because I had my own answer and I thought, it probably wouldn't be best for me to give it. Because my answer would have been, use a caisson rig. Right? You want the best way, the fastest way, use a caisson rig.
My answer to that, Dave, was I think you should probably hire somebody else. It goes back to the Beer Fest movie where it goes, what's a ZJ? And he goes, if you have to ask, you can't afford it. Listen, if you're trying to figure out best way to cut a 40-inch hole,
Well, right. You don't have the equipment to do that if you're asking, right? But you would possibly, if you have the equipment, could be done reverse, as long as you know have a pilot, and then you open a pilot, but you're probably opening it a couple times to get there. But now you're looking at, if you have a rig big enough to run that 40-inch hole, you should already know this. If you're asking the question, you don't understand the answer, because the first thing is exactly what we're talking about. Knowing, can I do this job? Because how often have you heard, yeah, you got into, I had a gentleman that's from Southern Illinois a few years ago asked me about a bid that he put on. And I looked at what he had bid. It was coming up here in Chicago. And my advice to him, I believe you were at the same show that I was at, what he asked me. I said, rescind your bid. Rescind it. You can't make money at what you just agreed to do. They snookered you for whatever reason. I don't know how, but you made it in such a way you're not going to make money. You're going to lose your shirt. He didn't rescind it. He won the job. I talked to him maybe it was 14 months later, something like that, when he posted a picture of him leaving the city with, oh my God, I'm so happy to be leaving because I've been bleeding money. And my thought was, of course you were. You didn't know what you were getting into. And there's a lot of reasons. I don't want to get into, it's his personal thing or the reasons, but it was clear from the bid you couldn't make money. And unfortunately, it was something someone from this area had to look into to know. Or he would have had to have asked some people who've drilled here to know what he had decided to do, that it wasn't going to work out for him.
That's a great point, Dave, because you just use the P word, and sometimes we don't like to do that because of as our tribal self-taught industry. But planning, we know that I got to drill this well for $7,500 because my competitor is going to do it for $7,500, or I'm going to get into this big municipal project and it's going to take me 15 months worth of work, and it's guaranteed work, and it's going to be perfect. But I just left $350,000 on the table. And one of my former colleagues went to another company and did just that. Everybody was bidding on the same project in the northeastern corner of Florida. And when the bids came out and we all looked and we went, they're going to do that for less than $1 million for 15 months worth of work? What were you thinking? And I can tell you that by looking at the former bids in the pre-planning phase, we went too simple, because drilling, we need to look at the pump we're going to set and the casing and the surface casing and the bit casing and all of those aspects. And we don't look at the drilling phase itself, because I can control the equipment I put on site. I can control the process on site. I can control the people that I put on site to make good decisions, and I can control the materials that I give them. I can't control some of the drilling phase because it's disruptive. It's my favorite saying right now, besides tribal, is we're doing the unknown. So here I am drilling the unknown, and there's X factors that are going to happen that I may have to cement off, that I may have to use a lost circulation material. I may have to change. And this magic bullet of reverse is the solution. Reverse is an excellent drilling method, and our engineers and hydrogeologists love to suggest it because it's the least amount of impact to the formation, because we're using a negative pressure to we're still doing the cutting action, but our cuttings go up the drill steel instead of outside the borehole, between the drill steel and the borehole wall. So our uphold velocities and all of the impacts and pressures. But there's a lot of complexities that have to get us to where we can effectively reverse, where a good mud engineer can come up with a great fluids program and do the same thing. And if you don't believe that, then our opposite tribe of us, the oil field tribe, how many reverse rigs are out there right now around the world drilling oil and gas stuff? There's two reasons that's not happening. One, we have to have a weighted fluid and we can't have an unbalanced system. But the second is because they've figured out how to maximize all of their drilling capabilities on a conventional fluid versus reverse. But back to your other point about our gentleman with the 40-inch hole to 120 feet, you know how that came up? And I've always been a great advocate of engineers until I got to the Southeast. And there's excellent ASR USA engineers, great. Stantec, great. CDM Smith, great. And if you're listening to this and I didn't name you, it's because I'm waiting to be out of my contract so I can talk about you. And it's because of harebrained ideas of, I need you to drill a 40-inch hole to 120 feet, slap 32-inch casing into it, and cement it up. And then I want you to go in and I want you to drill an 18-inch hole to 1,000 feet. Our uphole velocity calculations, now I have to run reverse because everything that I had thought of as a good, effective drilling program is out the window when I go from an 18-inch hole that is 13 gallons a foot to a 40-inch hole that is 40 times 40 divided by 24.52 is 65 gallons per foot. So guys, a cubic yard of material is 27 cubic feet. So I'm 65 gallons per foot. If I divide that by 7.48, which is a cubic foot, I have 8.7 cubic feet of material for every foot I drill. So I do my 30-foot stick of drill pipe. I am a 261 cubic feet. Divide that by 27. That's a dump truck per rod that I'm removing out of the hole. And where does that come back to? When I'm disposing of cuttings, if they're still in a fluid phase, that's the difference between $10,000 worth of vac trucks and $100,000 worth of vac trucks. And that comes into our planning of where we need to be and how this job's going to come out. And in the bid phase, we can look at all the material stuff and we can call our favorite retailer, we can call our pipe supplier, we can call everybody, we can do our calculation and times it by 2 and say this is what it's going to take to drill it. But we can't calculate how well our solids control units are going to work or where that material is going to go as effectively as we can. And then suddenly our disposal company that we've really liked using, it's spring and it's rainy and they've shut down. And so now instead of $500 a truckload, it's $2,000 a truckload because they can't take it into whatever magical hole that floods the Gnome Village. And they gotta process it through some other center.
You know, those gnomes, they get in our way all the time. Right? And I used to tell people, oh, it's the drilling gods. But you're right, it's probably the gnomes because there are so many moving pieces, like you said. You know, could this, with the right equipment, that hole be drilled? Yeah, it could be. But it comes back to, well, you've got a 40-inch hole that you're going to reduce to 18 inches? Doesn't make any sense. Because anyone who can drill that hole, it's like, well, wait a minute, why are we going to go from 40 down to 18 wouldn't make it, right? Because there's a reason that you want anything that you're setting in the hole that you're going to want it to be a certain size.
Well, we use pit casing and we stabilize in areas so that, you know, if there's sinkholes, right now there's one in Lakeland, Florida that has opened up that is just swallowing things. So, you know, you look at the ridge and whatnot that's going on in the Southeast, and there's reasons for deep pit casing, but There's nothing that can't tell me that if I ran a pilot hole first and determined where the competent rock started, and I set my pit casing to there versus an arbitrary, I need you to set 120 feet. So the big kids out in the industry have went, hell yeah, we'll set this 40 inch to 120 feet because we're going to charge you $200,000 to do it. And then a good reputable company, not saying the big guys aren't good, looks at, I can drill you that 18-inch hole to 1,000 feet. I am capable of doing all of this, and I have less overhead. And I can make a good living with my family, and I'd love to have this. But I can't do that top hole work for you.
Right.
And so what happens? They're not able to bid it. You know, we allow engineers and buddy big companies to determine what a spec is. And instead of us getting into the discussion that we've just had for, you know, almost an hour now on just cutting action and what it takes to create a hole, that's what you need to be able to have with your engineer, your design firm, your customer. When your customer goes, hey, I think I'd really like to have a 20-inch well instead of an 18-inch well. If you can go into the complexities and figure out what we're really trying to achieve, then we can be a better industry versus just going, all right, look at what these bozos have told us to do. How can we get there? And Dave hit that nail on the head. We got awesome caisson companies. We got awesome bucket rig companies, and we call them up and they're in the construction side and we go, hey, I need you to drill me this hole to 120 feet. Give me a lump sum price, not time and material day rate. Can you drill this 120 foot hole, 40-inch diameter for X dollars? And then you both have skin in the game instead of that Bauer rig or whomever shows up and starts spinning to the right. And, oh man, it took us 10 days to drill this hole instead of the 5. And now how do you put that into your bid?
Well, and it comes to playing to the strength of what's around you. And I learned that early on. We would get into some jobs. They would ask me to do some jobs when I was running one drilling company. That was much of the scope, or some of the scope would be beyond us. We don't have competitors. We have opportunities. You can partner with somebody, and they may not be in your same industry. But like you said, if I go to a dewatering company that runs a bucket rig, I don't own a bucket rig. They're not my competitor if I team with them for them to do that surface work for me. As long as I can trust that they'll do it right and that they'll come in, that if I have a lump sum, I have a known cost to put into my bid. And these things are important. And we get a little too wrapped up into, hey, me, I want to be able to do this, but we only have what we have. Nobody that I know of anyway can afford to put on, hey, we got this one job, let's buy a rig for it. It doesn't work that way. So somebody has the equipment that you need, talk to them about it. And then we can worry about how we make our portion of the whole and they can make their portion of the whole, and we can both be profitable because we're working inside our strength. And I think really that's what we should always want anyway. I mean, I know this was supposed to be a cutting action and we're talking about, but like everything that we do, no one thing doesn't react to something else. Everything is a chain reaction. So when we don't make the correct cutting action, or we don't use the correct method for the geology or the depth or the diameter, because that's where that reverse comes into its own, when all of a sudden I can't maintain uphole velocity because my hole's much, much bigger than my rod diameter. That's why reverse works, because I'm taking that and I can control it inside a known diameter of my pipe. And so I still have buoyancy. I still have cuttings removal. I still have all those things. I work inside my strength. When something's outside my strength, I either have to pass on it or partner, right? So we're going to either pass or partner with somebody in order to, but if we think about it that way, we can still be profitable.
And that's the key. When we look at that job and we look at that dollar amount, what is the risk versus the reward? What can I get done in the same amount of time? Midwest Geodrill, those guys, when we were doing cathodic and we were looking at the water wells and stuff, and the geothermal group was looking at all the cool stuff that they were doing, we had one rig we could do some cathodic with. That same rig we were doing water wells with. I didn't just take every project that was available to me. I laid down a map of the Midwest and I said, yeah, here's the research. I can drill this. Brian and Tyler can kill it at this stuff. We can use a 170 mud puppy to separate the solids, and we know the expectations. And you know what? We made money. And that's the key. When I look at this huge job, or I look at moving 65 gallons per foot for 120 feet, how long would it take me to drill a 40-inch, 120-foot hole? Now I look at my equipment, and Buddy Sebastian, one of my favorite quotes, we're not drilling for just beer and pizza money. You know, what is the maximum I can make a week with my drill rig? Can that drill rig make me $2,500 a day? Does it make me $1,000 a day? How many more days in this year, when I'm looking at Dave saying it's freezing in Illinois right now, how many more days do I have left to be able to maximize my year? And holy cow, it circles right back to cutting action and what I can cut. If I'm going to be in the Canadian Shield drilling cores into stick rock, how long is it going to take me? Am I going to be in the Southeast where there's sinkholes and karst environments and the Floridian Ridge? What amount of time and people and the variables? Because I want that sweet spot. I want medium risk work. I want it to be risky enough that I need the expertise and be the best damn person to do it. But I also want to make sure that I can complete it in an effective amount of time to move on to the next one without tearing the hell out of my equipment. And that all comes back to that rotation and cutting action. And then how the heck am I going to push that stuff out of the hole and stabilize that hole? How did we just simplify this? Because it's drilling, right? And if the hole isn't having cuttings taken out of it, it's not a hole. It's you planting a metal tree. The wrong type of metal tree, if you're thinking casing, you know, where are we going from here?
Well, and isn't that what all these podcasts are about? Really? All these podcasts, we start with a topic, we wind up at the same place. How do we be profitable? How do we be profitable? And the answer is that we stay inside of what we do. Even if we're that specialty company that can do those really difficult jobs that can really, be challenging for other companies. That's our niche. If that company starts taking some residential or small municipal work, they're not inside of what they're designed for, because that specialty company needs an awful lot more per hour to be profitable because of what they've invested in their equipment and the type of, so now they can't really make the money that they need on some of these small projects. So like you said, that medium risk changes. If I'm that company that only does residential work. But I have the opportunity to do some municipal work, something that might be inside of my equipment's ability, but it's right on the edge. Look at what is the risk, because can I deliver? Because we all know that it takes one little change. I won't say mistake. One little change in something to go from being profitable to not profitable in drilling, especially if we take the high risk stuff. And this is the problem with people getting antsy because their equipment sits. And this is why I wanted to bring it up. I know I see on your face you're going to disagree with me. It's fine. You can do it. But this is the problem that we get in. You get a company that is having slow time, so they want to find anything to put the rig on. And sometimes that's the death nail of the company, because they put the rig on something they really shouldn't be doing. And it goes from that rig not making money to that rig losing money, which is much, much worse.
Agreed. And I'm not disagreeing with you on the point about the one little changes the job from being profitable to not profitable. It's that way because that's our mindset. That is our mentality. I really enjoy mowing my lawn. I take pride in it. I don't have a riding mower. I just have a push mower, and I can spend 4 hours out there, and when it's done, it looks good, and my shrubs are trimmed, and I enjoy it. Do I think I'm an expert? No. Do I think I should take on a landscaping job for a massive golf course? No. So when we decide to step into something, we need to know where our profitability is. We need to know what we know about cutting a hole, about making the footage we need to be effective, how much fuel that rig's going to burn, and the time I'm there, and then make sure the profit is right. And just because your profit's been 18 to 22%, now you're taking this job on. If it's a job you really want, you need to make sure your profit is going to offset what you're going to miss out on. Because a lot of times we jump on other jobs, and we call those the quick money jobs because they're simple. There's no risk. But when we tie equipment up on something else that's going to take longer, we start losing that stuff. We start having that moment of the well from hell. And beyond that, the story I have on that is Ball State Geothermal. I was on the first phase of Ball State. There were 3 Indiana companies that came together that had the tribal knowledge because their tribe chiefs are there and they own Indiana. But, between the 100 years of history of the one company, Ortman Drilling, to Dilden Brothers and Moss, how they had drilled in that area, they were very comfortable. The other phase was a group of drillers from Minnesota, all very capable, very smart guys that have come from multiple different sides, and they all came together to converge on this job. And they came in with their tribal knowledge of Minnesota, which was good tribal knowledge. But at the same time, it wasn't the right applications to what they wanted to be able to do and how we needed to set those loops, from solids control to running augers in for their pit casing, to piston pumps that were just blowing that shale apart to the point that you had 10-pound mud weights and you couldn't put the loops in the hole. And then we compounded that with everybody was so excited to have that job that they let the engineer convince everybody that they should do dual loops with clips to 400 feet. And so the allure of having 1,200 holes, or 1,400 holes to start, and all of the work we had there really hurt the opportunity of being able to be successful. The Indiana guys went in there and they did fair. and they went on to do other geothermal projects. And I believe a lot of the Minnesota guys still do some stuff too, but it wasn't like this big win. And then we saw the Ball State project, because of the way the engineering was and the tribal knowledge, they just continued to allow the low bidder to come in and say, I'm from Texas. That means I should come to Muncie, Indiana and drill in this shale because I drill in shale in Texas and I know what I'm doing. And then we see the project, push out and push out and push out.
Well,
And I got one more point here, Dave. And then as I was working with the company in Grand Rapids, they bid a job in Los Angeles. Their tribal knowledge was the Midwest. They understand production. And their vice president and president and controller all made a decision on how that job would be run, put those guys out there, got them the right bits, made changes as it was, and it turned out to be a very good job for them. And I know some of those guys listen to this podcast, so good job. And I hope you're kicking butt in Washington right now, and I hope you kick butt on your next job. You figured out what it took to be productive, and then you also bid it the right way. And so we can take on high risk if we bid it as high risk, like our insurance company does, like our insurance is the best way to think of it. The higher the risk, the higher the premiums are going to be. And that's
we have to know where our threshold is. You're talking about Ball State. I was asked to bid that second phase in Ball State in conjunction with a few other companies when I was with the national geotech company that I worked for years. They had bought some water well companies and they wanted me to put the bid together, and they were upset that I looked at it and went, no. What do you mean? There's not too many people that are better than you at looking at this stuff. We should be able to do this. And I said, not with what you have, the way it was going to be done. The guys that you have are capable, but they're not used to what they're doing here, and they're asking for some things they're not used to. We're going to lose our butt. And they were upset that I didn't bid it. I was thrilled that I didn't bid it when it all came down, because we would have been in the same boat as those guys, right? They would have had to have put new equipment on there, or worse yet, they would have sent me out to the job, and Driller Dave would have had to show up and start making changes to these guys who we've purchased their company. They know what they're doing, and then I'm going to come in and tell them how they should run their rig, where their money should be spent, because they would not be right. I wasn't comfortable with it. It's not the role I wanted to be in. Unfortunately, I was put in that role a number of times. Sometimes I had to go be that guy. Sometimes I didn't. But knowing when to say, nope, that is not for us, because we're going to lose our butt. I have an example. We bid a project. This was same company. Their head driller, before I was the head driller, looked at the company. I was still a helper at the time. Looked at the job. Said, don't bid it. The office manager for the office in the area bid it anyway and won the job, and then had the head driller come out and drill it. And we lost our butt. They wound up sticking some casing and a bunch of comedy of errors on the job, not because they didn't know how to drill. They didn't have the right equipment for the job. So then after he proved his point, not on purpose, but he was able to say, look, we don't have that's why I told you not to bid it. They had to then sub somebody else to come in and do the work that should have been the type of company that got it in the first place. Without the right equipment, the right knowledge, you're kicking yourself, right? You don't want to be your own worst enemy. You want to make profitable decisions. It's the same as having a driller make good decisions. The person bidding the job that's trying to get the work needs to make the same kinds of good decisions.
And I think that's the perfect wrap up is just because we're good drillers doesn't make us great businessmen or women. And so it's very important for us to understand that. And the first step is our planning phase of understanding the cutting actions and how we mitigate the amount of disruption we do to the borehole and what we're able to drill. And in that tribal knowledge of us bidding projects and looking at things, we're successful in this industry because experience is knowledge. And so we get good at repetition in the things that our equipment excels at doing. And if we're going to step outside of that wheelhouse, and I say do it, I say try some cathodic jobs, get on some geothermal stuff. JAG on the Drilling Insight podcast just said we need more drillers than ever for the geothermal stuff coming out, in the Northeast and in the Southeast and throughout the country. So, being able to understand the disruptive process and adopt the idea that we can be surgical drillers, that we can step in, we can plan it properly, we can bid it properly, and we can execute effectively. It doesn't have to be a giant mud hole. It doesn't need to be $100,000 worth of vac trucks. We have to look at what the job's going to be. But if it's the only way we get good at something is trial and error, and that's what happened at phase 1 in Ball State with the guys on the North Field was, well, the next hole we'll have it figured out. You have about 3 holes to figure out your process when you're doing that. If you look at the blast hole guys or the mining guys that are doing coring, and Dave can attest to this, when we can get into one place with the same geology for 6 months, sure, there's going to be some variations, but I 100% should be able to kick that area's ass. And if you can't replicate that within your first 3-4 holes on that job, you need to stop, figure out what you're doing, call some people, call the other tribes that want to help you out, and figure out how you do it better before it costs you a big chunk of your livelihood in your company.
Well, the way I like to put that, and this last thing I'll probably say, is that if the geology is consistent, you have to be consistent, right? If the geology is not consistent, you can't be consistent, and that's a basic rule to follow, right? When the geology changes, I change it, but if it doesn't, I do what's going to work because it's going to make me money. With that, I think it's a great place to stop this podcast. So I'm going to say, on behalf of me, keep turning to the right. Unless, of course, you're doing dual rotary, then turn to the right and the left. And have a wonderful time until the next time we see you.
Yeah, this has been the Brock and Dave Drillercast. Today we've talked about drilling and the impacts of drilling and just the straight fundamentals. We're going to continue these thoughts. You can find Dave and I in National Driller Magazine and our monthly articles. You can go to thedrillerstribe.com. Pass this on to your friends, guys. This is all just tribal marketing on top of everything else. We're just a bunch of drill guys pushing this stuff out. We enjoy it. We want to get some of you on here. We want to have different topics. There's a lot of things going on, but really this is about community and the Drillercast and Drillers Tribe and the Facebook groups. And there's lots of groups out there, and we love participating with those too. And we enjoy everything we do with National Driller. It just comes back to how can we share more knowledge? And there wasn't a better way for me to spend my Saturday morning than hanging out with one of my good friends and having a discussion about drilling. So thank you, Dave. Thanks, everybody. Have a great week.
Thanks, Brock.